Hi class, today's lesson is about solving inequalities. These are lessons 1-6 and 1-7. So our driving question today, how are inequalities different from equations? Now, when I write this question, know that there will be more than one difference. So when you're writing your summary at the end of the lesson, I don't want you to just write one thing that's different about them, but all the things that you can think of that are different between inequalities and equations. Now, you might already know what an inequality is. You probably worked with them before in middle school. But either way, we're going to start with how to identify what an inequality is. Like, when do I even know when I'm seeing one? So an inequality will not have an equal sign. So inequality actually means not equal. But they will have greater than, less than, greater than or equal to, or less than or equal to signs. So you'll see one of those four symbols, and that's how you know it's an inequality. So, for example, if I see, let me circle it, this inequality at the bottom, how would I read that? Well, x plus 3, and then I see that that symbol means greater than, so x plus 3 is greater than 5. So that's one example of an inequality. And we actually can solve these, which is what we're going to get to next. How do I solve an inequality? Well, you actually solve an inequality the exact same way you would solve an equation, which we learned in lessons 1-1 and 1-2. Feel free to go back and review if necessary. But I guess I shouldn't say the exact same way because there is one difference. And that difference is that you have to flip the inequality sign whenever we multiply or divide by a negative. So let's look at an example of this. I have 2t plus 1 minus 4t is greater than or equal to negative 4. So I'm going to start as usual and distribute that 2. I have 2t plus 2 minus 4t is greater than or equal to negative 4. I do have to combine like terms. I see that I had that 2t and negative 4t. Together makes negative 2t plus 2 is greater than or equal to negative 4. I have to work on isolating that t now. So I have to subtract 2 from both sides. And I get negative 2t is greater than or equal to negative 6. Notice that I didn't flip the sign here. There's really no problem because we're subtracting. I know I see a negative, but I'm not multiplying or dividing by a negative. And that's actually the key here, that we have to be multiplying or dividing by a negative. Alright, so in this next step, to get t completely alone, it's currently being multiplied with negative 2. So I have to divide by negative 2. Now here, notice that that greater than or equal to symbol changed to a less than or equal to symbol because I did divide by a negative. I divided by negative 2. So my final answer is t is less than or equal to 3. Now it only changes the greater than to less than and less than to greater than. If it had that dash underneath before for the equal to part, leave that there. Alright, so what's really the answer? I know I saw t is less than or equal to 3, but there's a lot of numbers that are less than 3. So like, is 2 my answer? Is 0 my answer? Is 2.9 my answer? So what it really means is that any value that's less than or equal to 3 is a solution. So these problems have more than one solution. So solutions in this case would include 0 to decimals like 1.35. It would even include a 3 because 3 is less than or equal to 3. It would even have numbers really close to 3, like 2.999999999. It can keep going because it's, as long as it's less than or equal to 3, it's an answer. I could even go really far back, less than 3, like negative 1,000. Fractions work too. So 5 over 2, even though a 5 is there and that's bigger than 3, 5 divided by 2 is 2.5, which is less than 3. And actually there's an infinite number of solutions because there's an infinite amount of numbers that are less than or equal to 3. Because there's an infinite number of solutions, that's the reason that we just write our answer like this. There's no way that I could possibly write down and list every single possible answer. So instead, I just say, well, all my answers are less than or equal to 3, and I'll leave it at that. All right. Now let's talk about some that are not answers. So solutions do not include 3.00000001. So anything that's, even if it's really close to 3, if it's more than 3, it's not an answer. So 4 is not an answer, 20.5, 507. These are all just kind of random examples. 7 over 2, which is 3.5. And again, that there's an infinite number of solutions that are not answers. So I know that seems kind of crazy. I have an infinite number of answers, but I also have an infinite number of numbers that aren't answers. Yes, that's because there's a lot of numbers. All right, so the answer can also be shown visually or graphically. So you can write single solutions. You can write it in the notation t is less than or equal to 3. Or you can show it like this. So noted that a solid dot is used right at that 3 to show that 3 is one of my answers. And I know that 3 is one of my answers because it is equal to 3. And also, I had already written it up here under my solutions. So we use a solid dot to say, hey, this is one of my answers. And then we use a bolded line to the left of 3 to show that everything that's less than 3 is also an answer. Notice that I also bolded the arrow to show that this continues. So don't think just because I'm not showing, negative 1,000 on the graph doesn't mean it's not an answer. That arrow is saying every single number that's that way on the number line is a solution. All right, so now we're going to learn about compound inequalities. So compound inequalities combine two inequalities kind of in one with the words and or. So in order to find the complete solution, both of those inequalities that it's combining must be solved. So here's an example with the word or. So the prompt says 3t plus 2 is less than negative 7, or negative 4t plus 5 is less than 1. I start solving the first one by subtracting 2 from both sides. 3t is less than negative 9. I divide by 3 to see that t is less than negative 3. So that's one part of my answer. But I have to move on to the second inequality and solve that one as well. So I subtract 5 from both sides. Negative 4t is less than negative 4. I divide by negative 4 on both sides, and I see that t is greater than 1. So my complete written answer would be t is less than negative 3, or t is greater than 1. So what does that look like? So the graphical answer, we have our number line here. So you write it as if you're answering both or graphing both. First, I showed everything to the left of negative 3. Like, hey, t is less than negative 3. But then I also bolded the area to the right of 1 to show that t could be greater than 1. For the record, I forgot to note up here, the sign did flip on the second one from a less than to greater than because we divided by a negative. So in case you're wondering, that's why it went to t is greater than 1. Anyway, so both portions must be bolded to show the complete answer. Notice that in this one I didn't have solid dots, I have the open dots, and those are used to show that negative 1 and 1 are not solutions. So in this case, I can't say that, for example, 1 is an answer because 1 is not greater than 1. It might be equal to, but it's not greater than. So we use these open dots when you just see the greater than or less than signs. We use the closed dots when you see greater than or equal to and less than or equal to. So now let's look at an example with the word and. So here I see this inequality. And I know it doesn't look like if it's two inequalities, and I don't even see the word and, but it actually is. So this is saying -7 is less than or equal to 3m minus 4, and then on the other side, using the 11, 3m minus 4 is less than 11. So they wrote it in one just because they didn't want to rewrite that 3m minus 4. But technically, so it could be written together the way it is up top, or it could be separated using the word and. So even if you don't see the word and, know that this is a compound inequality. So as you know, we have to solve both of them to get our final answer. So I start by solving the one on the left. I add 4 to both sides, and I see -3 is less than or equal to 3m. And then I divide by 3 to see that -1 is less than or equal to m. This could also be read as m is greater than or equal to -1. It's just kind of being read backwards. So, again, just to repeat myself in case you didn't catch that last bit, I could also rewrite this the other way to show that m has to be greater than or equal to -1. Now the sign did flip, but I actually didn't change anything. It always has to stay facing the same numbers. So before, a lot of teachers in your past might have used like a Pac-Man or alligator as an example. It has to continue eating the same one. So before it was like facing the M, kind of trying to eat the M. So even though I move the M to the left, it still has to be facing that M. So it could be written or read either way. Now let's go on to solve the second one. I add 4 to both sides. See 3m is less than 15. Divide by 3 to get m is less than 5. So your answer could be written separately, the way I did in those two boxes with the word and in the middle, or the way they did in the beginning, it could be written as 1 with -1 is less than or equal to m, which is less than 5. Some people might also say m is between -1 and 5. So let's look at the graphical answer. So first, this is what the graph for m is greater than or equal to 1 would look like, or -1 is less than or equal to m. Notice that I didn't actually put it on the black line. I put it above right now just because I want you to see what it looks like, because that's not actually our final answer. If I just wanted to show you, it would be a solid dot because it has that equal to line on the bottom. And then everything would be going bolded to the right because it's saying m has to be greater than -1. Now the second part of our answer, m is less than 5, is shown in purple at the bottom. Notice that this one has an open dot because it doesn't have that equal to dash underneath. It's just less than 5. So the open dot is right at 5. And then the line goes to the left where everything is less than 5. So our final graphical answer actually has to combine both of these two together. So anywhere that you see that they would intersect, which would be right around this box right here. And as a matter of fact, I should draw it right on top. So wherever they overlap, that's actually your answer. They get combined into the middle. So my final answer, graphical answer, is shown right on the black number line. You when writing your answers in person, do not have to draw the extra lines on top and bottom. I just drew them for the purposes of showing you why this is our answer. So it is okay that one of the dots is solid and the other one is open, because that's the way our answer actually is. One of them has the equal to part and one of them does not. I know that I only gave one example for each one of the problems, and I normally give a lot more examples, but I knew that this was already going to be a rather long video, and I didn't want to make it too long for you. You will be doing more practice in class, as well as on Khan Academy. As always, make sure that you take good notes, that you write any questions that you have in the left margin of your Cornell notes. Feel free to email me if you have a lot of questions. Ask another teacher if necessary. But if not, I will definitely be reviewing this. I know this can be a bit challenging when I return next week.